A solid wooden rectangular prism measures 3 by 5 by 12. The prism is cut in half by a vertical cut through 4 vertices as shown. This cut creates two congruent triangular-based prisms. When these prisms are pulled apart, what is the surface area of one of these triangular-based prisms? Well, let's label this. It's already labeled. I'll just continue to label it the way they've done it. 12. This is 5. I think that should be good enough. The first thing I want to do is calculate that diagonal. And that can be easily done using Pythagoras. And that's going to be 13. And some of you already know a 5, 12, 13 triangle is a right triangle. All right, I think I'm ready to figure out the surface area. So the first one will be the top, the bottom and the top, and those are exactly the same. So it's 2 times 1/2 base times height, where the base is 12 and the height is 5. And then we will calculate that side, which is a rectangle. So that's just a 3 by 12 rectangle. And then this side here, which is another rectangle, it's a 5 by 3 rectangle. And then the last part is this shaded side, and that is what? It's a 3 by 13 rectangle. All right, so 12 times 5 is 60 plus 36 plus 15 plus 39. When you add up those numbers, you get 150. Number 17, the answer is D. A triangular prism is placed on a rectangular prism. As shown, the volume of the combined structure is. Let's first figure out the rectangular prism. That's pretty straightforward. It's going to be length times width times height. And our length is 6, width is 4, our height is 2. So that is 48. Now let's concentrate on this triangular prism right on top. So we have triangular prism now. And that one is going to be the area of the triangle, which is 1/2 base times height, times the width of that structure. So let's see here. Base is from here to here. Now they don't label that, but they do label this whole thing as 6. And they tell me that this is 3. So this must be 6 minus 3. So that means the base is 3. The height, which is from top to bottom, they don't give us, but they tell me that this whole thing is 5 and that this is 2. So this height must be 5 minus 2, which is, again, 3. And then the width from there to there is the same as the width from there to there. So that's 4. So we've got 9 times 4 over 2, so it's 9 times 2, which is 18. And now we've got to add them both up. And when you do, you get 48 plus 18. And that is equal to 66. So number 20, the answer is E. The numbered net shown is folded to form a cube. What is the product of the numbers on the 4 faces sharing an edge with the face numbered 1? All right, so we got something 3D, and as always, it helps to draw a diagram. Now, if you're practicing at home, absolutely nothing wrong with taking a piece of paper, making a diagram like this, taking a scissors, cutting it out, and folding it up to make a cube if you need to do that. There's nothing wrong with that, and actually encourage it. Or if you have a Rubik's Cube, you can just, do it that way. So what I'm going to concentrate on is the 5. It makes it easier for me. And I'm going to put the 5 up top. And then just bringing the folds down, this fold obviously would come down. So the 6 kind of comes here. This fold comes down on the other side, 3. And then this fold would come down to be here. And then now I think it gets a little bit, not necessarily difficult, but a little bit of visualization requirement. When you bring the 2 down, it will, this one right here, it will be on the same plane as the 3, okay? And the only other place the 2 can go in terms of our diagram, since the 6 went here in the front, and the 4 went over there to the left, and the 3 went over there to the right. Or sorry, the 3 is actually behind. And it should have been right behind. Kind of makes it easier, I think. 6 front, and then 4 is left there. I think that's a little bit better. So going back to the question, the only other place that the 2 can go in the same plane or the same level as the 3 is right here, which would be the right. So I hope that makes sense. So that means the 1, there's only one place for it, and it's right here at the bottom. So what are the 4 numbers that share an edge with the 1? Well, everything shares an edge with the 1 except the 5. So this 4 shares an edge, a 6, a 2, and 3. So they want the product of those numbers. So 4 times 6 times 3 times 2 is what they are asking. And that is 144. So number 14, the answer is B. 3 different views of the same cube are shown. The symbol on the face opposite the colored circle is. Let's try our best to figure this out. So I'll just start with this one right here, and I'll label it exactly the way it is. So we've got that square there, and then here we have that square with the X, and then here we have that circle. Okay, now where do I go next? I'm going to try to put that in. So based on the orientation, it looks like the plus could go here, and then the circle that's filled in will be the one that's at the very back. So like that. And then let's try to figure this out. It looks like the plus and the, I guess the square with the X are going to be sort of on the same continuum, which they are on this one. And then the shape that's a square that's filled in is on the bottom. So I guess that's what's going to be here. And I think that's the best way of drawing this. So what do they want? The face opposite the circle with that's filled in. So the circle that's filled in is on the back one, and therefore on the front one is this symbol here, this square with the X. So that's C for number 19. A solid cube is made up of white plastic and has dimensions n times n times n, where n is a positive integer larger than 1. The 6 faces of the cube are completely covered with gold paint. This cube is then cut into n cubed cubes, each of which has dimensions 1 times 1 times 1. Each of these 1 times 1 times 1 cubes has 0, 1, 2, 3 gold faces. The number of 1 by 1 by 1 cubes with 0 gold faces is strictly greater than the number of 1 by 1 cubes with exactly 1 gold face. What is the smallest possible value of n? I'll start with a simple example. Let's say n is 3. Well, if n is 3, then in a very sort of straightforward way, let's label this. So 1 by 1, that kind of thing. And I hope you can visualize that we will have a very kind of predictable pattern for how many have paints of one side, 2 sides, 3 sides, and or 0 sides. So if n is 3, right, it becomes a 3 by 3 by 3. So we'll make a little table. 3 gold faces when this is all painted, 2 gold faces, 1 gold face, and 0 gold faces. Well, the corners will be the ones that are painted gold, and on 3 sides. So 3 gold faces will be the corners. As I hope you can clearly see, this is one such corner. How many corners does a cube have? 1, 2, 3, 4, 5, 6, 7, 8. So this will always be 8, interestingly, no matter what n is. Now let's talk about 2 gold faces. 2 gold faces are these guys. That one, this one. And now those ones we have to figure out in terms of n. Well, it's going to be n minus 2. You're subtracting 1 and 2 from n. And then you have to multiply that by how many edges are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Every cube has 12 edges. So it's 12 times n minus 2. 1. 1 is basically, as you can see, in the middle. One gold face. You get that by n minus 2 again. Multiply that by n minus 2. Because it's going to be this times that. And the dimension of this is n minus 2, and the dimension of this is n minus 2. And then there's 6 faces, so each of those will have that, so you multiply by 6. And then 0 gold faces is the ones in the middle that you can't see. And that is basically a cube itself, n minus 2 times n minus 2 times n minus 2. So let's see, when n is 3, what happens? When n is 3, well, this number is always going to be 8. This number becomes 3 minus 2 is 1, so 12. 3 minus 2 is 1, so this is 6. And then this is just going to be 1. So add them all up, 27. Is n cubed equal to 27? It is. So as you can see, this all matches. If you can come up with this, you are set. Now the criteria is that the number of cubes with 0 gold faces is strictly greater than the number of cubes with 1 gold face. So 0 gold faces was this n minus 2 to the power of 3 right here. And 1 gold face was 6 times n minus 2 squared, this guy right here. And this is the inequality. So the n minus 2 squared from both sides cancel, and all you're left with is n minus 2 is greater than 6. Therefore, n is greater than 8. N has to be greater than 8. So the smallest possible integer value for n is 9, since n is greater than 8. And therefore, number 20, the answer is C. Three different views of the same cube are shown. The symbol on the face opposite circle is. All right, let's try to figure this out. Let's start with that one. So the square goes up top, the circle is here, and that square with the x in it is there. That takes care of that one. Now, in a very careful way, let's try to make that one. So the circle and plus sign I have to place somewhere, okay? I think the circle can go here. That's the one that's shaded. And then the plus sign will go here on the side. And then I only have one left. So I got this, the plus sign and the square with the x in it. And therefore, I think that square that's shaded goes on the bottom. So I'm pretty confident this is how you do it. So the symbol opposite this, well, here is that's on the back face, and therefore the symbol opposite would be on the front face, and the front face was this guy right here. So that would be C for number 18. A triangular prism has a volume of 120 centimeters cubed. Two edges of the triangular face measure 3 and 4 centimeters as shown. The height of the prism is. Well, the volume of this prism is basically going to be the area of the base times the height of that prism. And the volume they told you is 120. And then the area of the base, well, this is a base right here. So is this. I mean, I guess you would consider that to be the base, but it's the same as the top, right? The dimensions are the same, 3 and 4. So the area of the base is just a triangle, and it's 1/2 base times height. So I can use 3 and 4 as my dimensions. And that just leaves me with the height. So that's what I have to solve for. So cross multiplying, this becomes 120 times 2, and then divide by 3 times 4. And when you do, you get 240 over 12, and that gives me 20. So H is 20. Number 18, therefore, is B. The length of a cube edge is 1 centimeter. The surface area of the cube is. A cube, as you are well aware, has 6 faces, correct? And the length of each side they're saying is 1. Length times width times height will all be the same for a cube. And therefore, each face, here's one face, will have an area of just 1 times 1. Now there's 6 faces in a cube, so to get the total surface area, we have to look at all 6 faces, so 6 of those areas, and that would be 6 times 1, and that is just 6 times 1, which is equal to 6. So the total surface area of the cube is 6, and therefore number 11 is E.